Okay, today is the first video of the year, and we will be learning classifying real numbers. This is lesson 1.1, and in your interactive notebook, this should be page number 2, should be going on the right side. So our learning target, what we hope to achieve today, is first we hope that we can recall the different classes of numbers, like real numbers, rational numbers, integers, so on and so forth. And then, once we're able to recall the classes, what we want to be able to do is identify the class or possibly multiple classes that a number belongs. So first we've got to just review what the real number system is. So with the real number system, we've got lots of different classes, but the smallest class of numbers is the natural number class. So we've got this class called natural numbers, and the numbers that fall within this class are considered to be counting numbers. And those numbers are like, when you start to count, what number do you start with? You start at 1, then you 2, 3, 4, 5, 6, 7, all the way up until you can't really count anymore. So this is the smallest class of numbers, natural numbers. Well, the next class is whole numbers. And the cool thing is, all the natural numbers are also a part of the whole number class. So we've got this whole number class now with all the natural numbers, and the whole number class adds in the number 0. So now we've got all of our natural counting numbers and 0 that make up the whole number class. That's why I'm drawing the circle around the natural numbers, because they're also whole numbers. However, 0 is not a natural number, it's just a whole number. The next class is the integer class. And so all of the natural numbers and the whole numbers also fall within the integer class. And these are considered to be the opposite numbers of our natural numbers. So our opposite numbers of natural numbers, which would be like -1, -2, -3, so on, so forth, -100, -200. So our integers are the opposite numbers of our counting numbers. So now we've got our negative numbers essentially. Now the next class is rational numbers. So we have this rational number class. And these are fractions and decimals. However, we've got to stipulate what type of decimals, because not all decimals are rational. So the type of decimals that we'll see in here are ones that end or stop. So ones that stop. Decimals that stop or have a pattern. So what does that look like? Well, obviously fractions would be like, 11 over 2 or -8/5. These are fractions, right? And then decimals that stop would be like 5.253, right? So eventually it ends. There's no ... doesn't go on forever. Or decimals that have a pattern. So maybe we have a decimal like 0.0333, and there's a clear pattern. If I had to guess what the next number was in this pattern, I would guess 3 because I can see that all the numbers before it were 3. So this is a decimal that doesn't stop. However, there's some pattern to it, so it's considered to be a rational number. And now what we have is this unique group called irrational numbers. And this irrational number group includes decimals that don't stop, that never stop. So obviously the decimals that never stop and have a pattern will be rational, but decimals that never stop that don't have a pattern, or the next number in the pattern or sequence you can't predict. So an example would be like -5.2597213 ... I can't really guess what the next number after the 3 is going to be. So this is an irrational number. Negative numbers, positive numbers, doesn't matter as long as the decimal doesn't stop and there's no pattern to it. And this group is by itself. It's exclusively on its own. And now these two major groups, this rational number group and all the smaller classes inside of it, and this irrational number group, make up the largest group, which is our real number group. So all numbers that we know are real numbers. So this is the biggest class, and it includes all of these other classes, and that is just the worst circle of all time. Sorry about that, and we're having some difficulties with the screen. No worries though. So all these classes fall within the real number group. Alright? So let's go ahead and get into a couple examples today. So very, very important is these codes over here to the left, and instead of having to write out, whole number, natural number, real number each time, I have these abbreviations that we're going to use to be able to identify what class a number belongs. So you can see here that we've got the real number classes are irrational will be used as B, Y, B, because it's irrational, we don't know why. And rational will be used as Q, Z will be integer, W will be in a whole number, and then our natural numbers will be used as N. So what I'm going to do is I'm going to look at the number, and then I'm going to figure out the smallest class. So if we go back to the previous slide, the smallest class, okay, that the number belongs. So the first one that the number appears, and then I know that all the other classes that it falls within are the circles that are larger than it. Okay? So if I look at 0, right? 0, the first time that we see 0 is in the whole number group. So that means that 0 is a whole number, however, it's also an integer, and it is also a rational number, and it is also a real number. So under the code for 0, I would write whole number, integer, integer, rational, real. So it's not just a whole number, it's also an integer, rational, and a real number. So it fits in 4 classes. Now what about negative 18.2? Well, it's a decimal, and I know the first group of numbers that are decimals is either going to be a rational number or an irrational number. So is it a decimal that stops, or is it a decimal that goes on forever and doesn't have a pattern? Well, it looks like the decimal stops. So I know that it is a rational number, and if it's a rational number, I know that it's a real number because all rational numbers are real. Cool? Negative 5. Well, I know that 5 is a counting number because I can count to it, but negative 5 is the opposite of a counting number. So what's the group that has the opposite of counting numbers? Looks like it's integer, so I know that negative 5 is integer, rational, real. Square root of 16. So what I've got to do to figure out the square root of 16 is I've got to convert this to a number. So what I'm going to do is I'm going to pull up the calculator, and I'm going to type in the square root of 16. So here's the square root button, and within it I'm going to type in 16. And then I'm going to hit enter. And what we get is 4. So now we've got to figure out, okay, where does 4 belong? Well, 4 is a counting number. And I know that all counting numbers are natural numbers, also whole numbers, integers, rational numbers, and real. Last one, square root of 15. I'm going to do the same exact thing. I'm going to open up the calculator feature. I'm going to type in the square root button over here. Then I'm going to type in 15 and hit enter. And what I get is a decimal that looks like it stops. But I'm going to tell you right now that any number that is in the square root that comes back as a decimal actually doesn't stop. Even though it stops within the calculator, this is a decimal that never stops. So decimals that never stop, and clearly this decimal does not have a pattern, is a irrational number. So this is going to be B, and all irrational numbers are also real numbers. So let's go ahead and see what our problem set will look like tonight for homework. Example number 1. Classify the following numbers into the subset which they belong. So before I can classify the entire group, I've got to classify each individual number. So what I'm going to ask you right now is to pause the video and try to classify each individual number, and then once you've done that, I want you to play the video and see if what you classified them as is the same as what I classified them as. Okay, so you can see here that I've categorized and classified each of the numbers. So now what I have to do in order to figure out which they all belong is to see the classes that they share. So for example, you can clearly see that almost every single one of these has an n, but not every single one of them has an n, because 0 is not a natural number. So I cannot say that these numbers are all natural numbers because 0 is not a natural number. However, they all have a w, so I can say that they're all whole numbers. They also all have a z, so I can say they're all integers. Can't spell, sorry. They all have a q, so they're all rational. And they all have an r, so they're all real. So this group is whole numbers, integers, rational, and real numbers. Example number 2. I'm going to ask you to do the same thing, so pause the video now and try to classify each of the numbers individually. Okay, so you can see here that I've classified all of the numbers individually. It looks like a long process, but the more you do it, the less you have to write them all out, obviously. So now let's figure out the class that they all belong. Well, they all do not have a n, so they're not all natural. They all do not have a w, so they're not all whole. Because you can see here this -6 is not a whole number or a natural number. So the first class that they share is this integer class. And I know now that if all the numbers are integers, that they also have to be rational and they also have to be real, because those are the two groups that the integer group falls within. Example number 3. Go ahead and pause the video now and try to classify each of these numbers. Okay, so I've classified each of the numbers. We've got integer class, we've got some rational numbers, some fractions, and some decimals that stop. And then we've got this decimal right here that has the ... So you're thinking, oh, it doesn't stop. It can't be rational. However, it's a pattern like we talked about. We know that the next number in this pattern is going to be a 3, so it fits within the rational group. So let's classify the entire class. So we know that they're not all natural numbers. 5 is the only natural number here, so we can eliminate that class. We can also eliminate the whole number class. They all don't share a w. They all do not share a z. They're not all integers. We've got a bunch of decimals that are not integers. So the first group that they all share is the rational group. And I know that if a number is rational, that it is also real. So this is a rational real number group. Last example for today. Go ahead and pause the video and try to classify all of these numbers. Okay, so you can see that I've classified all of these numbers. We've got rational number, fractions, rational number, decimal that stops, even though it's got a ton of numbers behind the decimal, it eventually stops. There's no ... We know that it's rational. And then we get to this number right here, this decimal number that has a ... Well, I've got to decide, is there some sort of pattern to this? 1, 5, 1, 7, 8, 4. Can I predict with certainty what the next number is? Nope. Doesn't seem like there's a clear pattern, so I know that it's got to be irrational. It's a decimal that goes on forever with no pattern, irrational. And then obviously we've got our natural number. So what class or classes do they all belong? Well, they're obviously not natural, whole, or integer. Are they all rational? Well, 4 of them are rational, right? But this one right here is irrational, so we can't say that they're all rational. Are they all real? Yes, they are. They're all real numbers. So we can just say that these are all real numbers. At this point, go ahead and start the problem set. Do the best that you possibly can. Remember, the requirement for the problem set is to pass at an 80%. So if it takes you a couple of tries, no problem. And go ahead and message me or post in Schoology, and either I or a classmate will help you through the problem set. Good luck.